Hello guys. So in this video, I'm going to be talking about multiplication and division of fractions. Multiplication and division of fractions. But I'm going to start with multiplication. So let's say that we've got two fractions like this. And we are supposed to multiply these two fractions. 2/3 times 6 over 20. So to multiply, you always want to multiply across like that. So you're going 2 and then times 6 on top. You do it for the numerator, and then you're going to do it for the denominator. So we're going to start with the numerator first. So we're going to go across, and then we're going to have 2 times 6, which is 12. And then we're going to go to the denominators, and that we've got 3 times 20, which gives us a 60. Now, can we reduce this? Yes, it is possible to reduce it. Can you see that? Okay. So to reduce it, you could start with a 2, or with this, you could, if you can see, you could see that a 6 will go into both of them. So I would do 6 and then do 6. So yes, you could have used a 12, but that's fine. Let's use a 6. So this would give me 2, and then this would give me a 10. Can I reduce it some more? Yes, I can use a 2, which will give me 1 and 5. So 2 divided by 2 is 1, and then 10 divided by 2 is a 5. So this brings me to 1/5. So it's it's always good to just multiply across and then fix it. If it's possible to reduce it or simplify it, you could also do that. Now, sometimes it is also good to see through the problem and then try to simplify the fraction some more before you multiply across. Like with this problem, first of all, I'm going to look at the fractions separately. I'm going to look at this, 2/3. Can I reduce it? Nope. I'm going to look at 6/20. So 6 over 20, and then see if I can reduce it. Yes. So I would first decide to reduce this, and then I'm going to have, oops, I'm going to have 2 will go into this 3 times, is going to go into this 10 times. You see it? So I've got 2/3 times 3/10. 2/3 times 3/10. Now, another thing about multiplication is that you could also, apart from looking at the fractions separately, you can also go this way. You could go diagonally like that. You could check if you could reduce that way, and then you can check these two as well. So I did the fraction separately and then reduced the 6/20th to 3/10. Now I'm going diagonally to check if it's possible, and it is possible to reduce something. So if I look at the 3 and the 3, 3, that could cancel out to give me 1 and 1. So I'm going to do that. 1 and 1. So 3 will cancel this 1. So I've got 1 and 1. And then I'm going to look at the 2 and then the 10 as well. 2 and then the 10. That I could also simplify with the 2. So I'm going to do that. So with that, I'm going to have 2 will go into 2 one time. 2 will go into 10 5 times. So now on top, with the numerators, I've got 1 and 1 left. At the bottom, I've got 1 and 5. So I'm going to multiply across. Now I can multiply across. 1 times 1 is 1. 1 at the bottom is 5. 1 times 5 is 5. And you could see that that brings me to the same thing. So what I want you to remember is that, yes, you could look at the fractions separately. That's fine. It's fine to do that. And then you could look at them separately, and you could also look at them separately and then check if it's possible to reduce. And then you could also look at them this way. Now, it doesn't matter where you start from. Like with this problem, I could decide to go diagonally with 3 and 6. Now, I can see that 3 and 6 will work by dividing both of them by 3. 3 divides into 3 one time. 6 or 3 divides into 6 two times. So this time I did the diagonal first. And then now here I've got 2 over 20, right? 2 over 20. Can I reduce 2 over 20? Yes, it's possible. You could do that. So it's all about you knowing the rules. I can go diagonally and then I could look at the fractions separately. That's how you reduce it. Now, this helps because sometimes when you multiply across, you're going to get very big numbers and it's difficult to reduce them or simplify. So it's always better for you to reduce it before you multiply across. So I can look at 2 and then 20 here and then try to reduce it. So I'm going to use a 2 this time. And then if I use a 2, 2 will go into 2 one time, 2 will go into 20 10 times. So now I have 1 over 10. But can I look at this? Because it's still diagonal. Yes, I could. So you could follow it in different patterns and you should get the same thing. It doesn't matter. You should get the same thing. So now I'm going to look at 2 and 10. And with that, I'm going to use a 2. 2 goes into 2 one time. 2 goes into 10 5 times. So you see where this is going? 1 times 1 on top is 1. And then 1 times 5 is 5. Same thing. So it doesn't matter where you start from. That's what I want you to understand. You should arrive at the same answer. You should arrive at the same answer. So let's try another one. So I have 6 over 24 times, let's do 6, or I've got to change this a little bit. 3 over 15. Now, the first thing, or probably the fastest way to do this, is to multiply across. So someone would decide to do that. Well, that should work, but what you're going to have is that you have 6 times 3 is 18. 24 times 15 is 360. So you would see that here you have big numbers, 360, at least for the 360. So can we reduce this? Yes. But now you're going to go through the struggle of trying to find factors that would reduce these. To avoid that, you could check each fraction separately, or you could go diagonally and then see if this should work. If it doesn't work, you leave it alone. If it works, you reduce it. Okay. Again, you could first look at the fractions separately. It's all on you where you want to start from. But here I would like to start from 3 and 24 and reduce it. Try to reduce it. 3 and 24. So 3 would go into 3. 3 divided into 3 one time. 24 divided by 3 is 8. Okay. So I've got 1 over 8 for that. I mean 1 and 8 for that. Now, what about looking at 6 and 8? 6 over 8. Is that possible to reduce? Yes. I could use a 2, so I'm going to use a 2 to do that. 2 goes into 6 3 times. 2 goes into this 4 times. Wow. Now, what about 3 and then 15? That is diagonally, if you look at it that way. Yes, 3 and 15, 3 could go into both. So I could use 3 for both of them. 3 goes into 3 one time. 3 goes into 15 five times. And then at this point, I think I'm done. So 1 times 1 on top is 1. 4 times 5 at the bottom is 20. So this whole thing, 6 over 24 times 3 over 15 gives me 1 over 20. Now, with what I did initially, I got 18 over 360. Now, if I want to reduce this, because I have the answer, you could clearly see that the top has to be 1. So 18 must divide into 18. And then 18 divide into 360, that should give you 20. So this will give you 1, that will give you 20. Now I know because I've got a cheat code. I'm trying to cheat because I already know the answer. But if you don't know that, 18 will go into both numbers. Then you have to do a 2 or do a 3 and then take your time and then keep reducing it. And sometimes that could be stressful a little bit. All right. One more on multiplication, and then we're going to move on to division. So let's say that we've got 9 over 20 times 25. 9 over 20 times 25. Now, you should see that, well, you could pause the video and then try it by yourself, but you should see that 25 can be 25 over 1. So now you can pause it and then try it by yourself. I would look at the fractions separately, but here you cannot reduce 9 over 20. So that stays 25 over 1. There's nothing you could do about it. So it stays. So what you could do is probably look at the diagonal part, this and that. 9 and 1, it stays. But what about 20 and 25? Oh, yes. I could reduce 20 and 25. I could use a 5 to do that. So if I use a 5, 5 would divide into this 4 times. 5 would divide into this 5 times. And I think that's about it. So you multiply 9 times 5 is 45. 4 times 1 is 4. Again, you could have avoided that and just do 9 over 20 times 25 over 1. 9 times 25, that should give you a 5, and then 225 over 20 times 1 is 20. And now you've got to find a way to reduce this. You could use a 5, 5, and then 5. This will give you 45. This will give you a 4. So you could also do that. But what I'm saying is that you're going to get bigger numbers, and you don't want to work with bigger numbers. All right, I said I was going to move to multiplication, but I'm going to do one more problem on multiplication, which involves three fractions. Three fractions. Okay, so let's do that. So what about if you have this? Three fractions. Now, the same rule applies for multiplication. You could just go across and then multiply and then do the same thing at the bottom. It's okay to do that, which means that you're doing 2 times 3, which is 6. And then you're going to do 6 times 16, which is 96. And then at the bottom, you're going to do 4 times 22, which is 88, times 6, which is 528. 528. So this is an example of what I'm talking about. These are big numbers. And it could be difficult a little bit or stressful to reduce it. Well, we could try these fractions separately and see if we could reduce them. And then you could always go diagonally. Yes, you could do that. But this time, because you have these fractions are three, there are three of them, you've got to take your time. So it's possible to reduce these separately. Let's check. So 2 and 4 for this. Yes, this is 1/2. I could reduce it to 1/2. Wow. What about 3 and 22? Nope. What about 16 and 6? Yes. 2 goes into this 3 times. It goes into this 8 times. Now, I'm going to check diagonally and then see if it's possible to reduce this. Now, because there are 3 fractions, you've got to take your time. You got to take your time. Now, you could look at this and that. You're going this way. 2 and then 3. That doesn't work. You could also look at 2. You're going diagonally, but you're going 2 and 8 that way. 2 and 8. It's also possible to do that. So long as it's diagonal, it's fine. So long as it goes that way, it's fine. So 2 and 8, you could reduce it. If that doesn't work, here it's going to work. If that doesn't work, you could look at 22. So I'm going to look at 22. And then 8, like that. You could also look at that. 22 and 8. You could look at that. It's possible. Okay? 22 and 8. 22 and 8. And then you could also reduce it if it's possible. If it's not possible, then you just leave it. Okay? So it's all about you taking your time to do it. Someone would also decide to reduce it like I did for 2 and 4, and then now the person is going to multiply across and then finish it at the end. It's also possible to do that. So I'm going to rewrite the problem again because it's a little messy. So I had 2/4 times 3/22 times 16/6. So I can reduce 4 and 16, right? So 4 will go into itself one time. It goes into 16 4 times. Boom. And then I'm going to look at 2 and 22. 2 goes into itself one time. 2 goes into 22 11 times. Wow. Now I have 4/6 here. I'm going to reduce that because it's possible, because I'm considering that as a separate fraction. So 2 goes into 2 2 times. 2 goes into 6 3 times. And then I could look at 3 and then 3 here. That's also diagonal, right? 3 and 3. So 3 goes into 3 one time, 3 goes into 3 one time. Wow. So now on top, I've got 1, 1, 2 on top, the numerators. 1 from left to right. 1, 1, 2. 1, 1, 2. In the denominator, I've got 1, 11, 1. So now I'm going to do 1 times 1 times 2 is 2. 1 times 11 is 11 times 1 is 11. Wow, 2 over 11. So this whole multiplication problem becomes 2 over 11. So 96 over 528 is 2 over 11. And you can see it if you decide to use 48 to divide between these. 48, 48. 96 divided by 48 is 2. 528 divided by 48 should give you 11. Wow. And that's it. All right. Now I'm going to move to division. Remember, you could always send your questions, post your question here in the comments, or send them to me privately and by email, and I'm going to help you with that. Division. Division. So let's start by using 2/3 divided by, let's do 4/9. So in division, this is what you do. You've got to keep this fraction as it is, change the sign to multiplication. So change the division sign to multiplication, and then flip this fraction. Keep the fraction on the far left, change the sign to multiplication, and then flip the fraction on the right. Now, flipping the fraction in mathematics is called find the reciprocal. Find the reciprocal of the fraction. Flip it. So keep change flip. This will give me 2/3 times 9/4. 2/3 times 9/4. Now, this brings us to multiplication. So in division of fraction, you've got multiplication in it. So now you can either multiply across or simplify before you multiply across. 2 times 9 is 18. 3 times 4 is 12. Can I reduce this? Yes. I can use a 6 and then a 6. This gives me 3. This gives me 2. 3 over 2. So this whole division problem brings me to 3 over 2. 3 over 2. Now, I'm going to end this video here and then do more problems on divisions in another video. So watch that video. Bye.